Hi everyone, welcome again to the CSEC Physics Masters platform. This is the final part of a two-part video on vectors. In part 1 we looked at how to add and subtract vectors that are moving along the same line. And we also looked at how to find the resultant of vectors that acted at right angles to each other. In part 2, however, we are going to be looking at the components of vectors. Something that is very important, as it can be used to accurately calculate problems from several different topics, and something that each and every physics student should know how to do. If you have not yet subscribed to this channel, please do, and give this video a thumbs up while you're at it. And do not forget to click that notification bell, as we will be going through the entire physics syllabus, and you want to get these videos as soon as they are posted. Now let's jump right into the meat of the matter. Any vector that has a slanted orientation is made up of two distinct components. That is, every vector that traverses in a slant direction has both a horizontal component and a vertical component. The direction of the vector does not matter. As long as it is slanted, one can consider the two components that causes it to be this way. Analyzing this diagram, we see that vector v in blue assumes different slanted orientations. But whatever the orientation that is taken by the vector, you can see that there is always a vertical and a horizontal component that is associated with it. And these components can be found using basic trigonometry as shown in this diagram. From this particular vector diagram, we see that whenever the angle is between the vector and the component being considered, you use cos. That is, the horizontal component is equal to v cos theta. But whenever the angle is not between the vector and the component being considered, you use sine. That is, the vertical component is equal to v sine theta. Let us take a look at this worked example that is alongside this practice question. The work example reads that a force of 20 newtons acts on a box as shown in the diagram below. Calculate the horizontal and vertical components. As you can see, the horizontal component is equal to 20 cos 30, where the 20 is the vector and the 30 is the angle, while the vertical component is 20 sine 30. Now, cos was used for the horizontal component because the angle theta was between that horizontal component and the vector, while sine was used for the vertical component because the angle theta was not between the vertical component and the vector. Let's go over and look at the practice question. It says that a rope is used to pull a barge at constant speed along a narrow river with a force of 300 newtons. And you are being asked to calculate the horizontal and vertical components of this 300 newtons force, which is just a simple brain teaser to test your skills just to see if you understand. It also rounds out the culmination of this particular video and the topic of vectors on a whole. Please remember to like, share and subscribe, guys. And thank you very much for watching. Peace.